Great. Welcome to the WiDS first place 2023 Datathon winners call. This is Maggie, and I'll turn it over to Sharda for introductions.
Hi, Maggie. Thanks, Maggie. My name is Sharda Kadanidi. I'm a director of data science at Stanford Med School, and I've been involved in WiDS for many years now, particularly in the preparation of the data set. I'd like to congratulate you guys, Evgeny and Elham, for outstanding performance, fantastic performance in the WiDS Datathon, and I'd like to welcome you to our recording. And we're really excited to hear about your presentation, about your research, what you worked on the problem, and your solution. And I'd like to also welcome Valerie.
Thanks. My name is Valerie, and it's a pleasure to meet both of you. I have been with WiDS for a while, and I'm the WiDS Datathon Program Director. And it's wonderful to connect with both of you. I'm really curious to hear about your experience with the Datathon. And as you go through and introduce yourselves and go through your presentation, I'd also love to hear about how you both came together to meet. I understand that you both didn't know each other prior to the Datathon. And so as a part of your share today, I would love to hear how you both came together to compete in the Datathon, and I'm really excited to hear about the insights that you gained. So I will let you both introduce yourself and share your presentation.
Thank you. Nice to meet you all. I'm very excited to be here today. My name is Elham. I'm a data scientist at IBM, and before this, I studied my master's in data science at the University of Michigan, School of Information, and it's been 1 year that I've been graduated. And the way that we got to be teammates was that Kaggle leaderboard. We could see who wants to be into a team. So I emailed Evgeny, and we shared some ideas, and we had a session, we talked together, and we decided to work as a team, and it was a great teamwork. Yeah.
Hello, everyone. It's great to be here. My name is Evgeny, and currently I'm a researcher at Elham, working in finance. And my background is in mathematics and economics.
Wonderful. Thank you. Well, would you both like to launch into your presentation and share with us?
Sure. Let me share my screen.
I'd also be interested to learn about, how your background affected your approach, any unique insights, any unique perspectives that you gained from your background. I noticed one of you, I think one was a mathematician, other was a data scientist. I'm just really curious to hear how your backgrounds affected how you explored your exploration of the data set.
Sure. So just we give you to that question during the presentation. Just reviewing the agenda, we are going to give the summary, and then we will talk about the feature selection and feature engineering, and we will talk about the training method and also some key findings and key ideas that helped us along the way. So just a summary, we used lasso regression for each location, and then we used some boosting method to predict the residual and correct our prediction for the regression. And the tools that we worked with was mainly Python and also scikit-learn. And features that were important, they were actually a variety of features, but I think the one that were most important were those that were in the same horizon as target variable. And the processing time was varied, but it was between 5 minutes to 2 hours, depending on what parameters we are selecting for each model. So feature selection was very important in this competition. We had around 250 features, and obviously not all of them would add value to the model. So we tried different methods, and selecting subset of features was really helpful. As I said, those features that were in the same horizon help us to reduce the RMSE. And we had different set of features for the regression and also for the boosting. We also found that some of the model predictions that we had, for example, enemy ones, were very important. That was kind of surprising because they were constant for over 1 month, but we found that they are helping the prediction, and also adding lag features were helpful. For the boosting, we removed highly correlated features, and by doing that, we could improve the prediction as well. I pass it to Evgeny for explaining the training methods.
Okay, thank you, Elham. So the way we split the data into train and validation is for each location, we took first 670 points as train and the last 61 points as validation. And so we saw that a lot of public notebooks, they split the train and tests using, for example, k-fold cross-validation. And it seemed that it was very easy to leak information in the case that we just randomly split the data. So that's why we wanted to have some piece of data that's in terms of time that we wouldn't see out other observations during the same time for the train. So for each location, as Elham said, we used lasso regression for prediction, and that gave us our initial prediction that was already very good. I think we got our RMSE of 0.62 after that. But we had several features that we were not able to use in the linear regression, specifically some categorical features. And the algorithm that came to mind that deals well with categorical features is the cat boost. So what we did is we weren't able to apply cat boost for each location because there's too few points in each location. So we bundled all of them back together and used cat boost to predict the residuals of the regressions that we found in the first algorithm. Then we did similar things with XGBoost and LGBM. I think cat boost worked best, but we combined them with weights proportional to their performance. And that's how we got the final prediction. And I guess it's important to say why we started with a regression. And we saw that many teams start with more difficult algorithms like neural networks or boostings from the very beginning. We saw that there is high correlation between some of the features and the target variable. And that really hints that a linear method would be a good start. That's more or less it. I guess our solution is maybe very simple.
That's great. Could you talk a little bit about maybe some exploratory analysis that you did in the very beginning? Maybe you looked at cross-section data or geographic relationships. I know you had picked some, you talked about a bit of that. If you can talk about some of the cross-section relationships perhaps, and then obviously the time series relationships that you had observed, perhaps. Is that something you can talk about?
Yep, I think the most important observation that we saw was that the correlation between some of the X variables and the target are close to 95%. So that hinted that we already have quite even if we take just one feature that's highly correlated, that would be already a good predictor. Or maybe we would need to scale it somehow, since correlation does not mean we could just predict the variable with that X. So that was the first observation. Elham, help me out. What else did we observe?
we also visualized the location, longitude and latitude of each location, and we found that it's like a US map. And we found that locations that are closer to each other have similar climate as well. And at some point, we wanted to use this closeness for prediction, but it wasn't something that is helping us. We went to that route, but it wasn't helping us. So
it wasn't all of the US. I think it was just the part from California to Texas, right? Roughly.
Florida.
Yes.
Yes.
Florida. Okay.
Yes.
I see.
Yes, but
Yeah.
it was it was all the important lats and longs, and we tried in the data preparation, we tried to cover the important longitudes and latitudes in the United States and have a good distribution of the lats and longs. So that was something that we were really curious about, whether people would pick up on that and the climate regions, because we wanted to be representative of the United States. And some people picked up on it and some people didn't, and it's good that it worked for you. I mean, and you picked up on the linear nature of the relationship, and different people pick up on different things.
One feature that we tried to add to our model was the coastal feature. So we figured out where the coast is, and we read that El Nino acts different on the coastal areas and on the non-coastal ones, but unfortunately that didn't help us.
Yeah, I think the kind of the parallels are very important, because they're the latitude the parallels, because they kind of are climate zones, and that was how the data set was sort of structured, to pick up on the different climate zones, parallel and the longitude across the United States. So I think that when you're looking at the correlations, yes, I'm sure you observe that yes, they are more correlated to each other. And also I think temporally there were certain relations, and I'm sure you picked up on that with a linear regression and picked up on those relationships as well.
Yes. We also tried to make ARMA-type models, because clearly we could predict the first point much more easily than the points after that. And we actually observed that even though the targets were set to be from 2022, from year 2022, if we kind of draw the time series, the train and the test together, it seemed that it wasn't from 2022, but it was just the next 2 months.
Yeah. So this was a part of a bigger model, and that was developed. And we, after doing a bunch of tests, a lot of testing, we realized that, we could set it at various levels of difficulty. We could set it and the further we go out, it's much harder to predict. And, we had the choice of setting it, much further out or close enough to the predictions where it's accessible to beginners. They can, build a decent model. And it's, people who have built models before it's challenging enough for everybody. So that was kind of our sweet spot. But, but you're right. We could have, built various intervals of prediction that would have been perfectly fine as well. But with this prediction, it looks like you were able to identify the patterns for this particular challenge. Yeah. What did you try? Other type of time series sort of modeling as well? Did you look at various kind of other time series approaches?
Yep. So we tried ARMA-type models, autoregressive models.
Yeah.
And, because of the observation that I said that it seemed that the test was actually not from 2022, but it was just the next few months after the train.
Yeah.
We saw that we can predict the first couple of points very well,
yes,
much better than the other points. But since it added a lot to the code, we just disregarded that observation.
Yeah, fair enough. I think that whether you pick up the predictions through the cross correlations or through time series, I think you managed to pick up the model one way or the other. right? And the linear regression picking up, but the bulk of the prediction, I think, it worked. You don't need a very complicated model if a simple linear regression, fit explains most of the outcome, right? And so it was a simple model, and it is done very well. I'm curious if you wanted to continue modeling, if you wanted to continue researching sort of this data set, what questions might you have had, or what questions might you have pursued? Were there any interesting questions that came from this data set that piqued your interest?
So you mean if we were to solve some other problems using this data set, like what would they be?
Yeah, I mean, were there interesting questions that came from this data set? Sort of interesting modeling or technical questions that came from this data set that you might have wanted to explore some more?
So one question that came to mind was, should we predict weather based on elevation differently?
Yeah.
And this is something we explored, but I didn't have much success with it. I mean, elevation definitely added to the boosting features, but that's about it.
I was curious also to know if we could predict precipitation as well, and if our modeling would predict that as well, or we have to change things for that, or if you have to change, what would help to have a better prediction for precipitation as well.
I see. And what were your observations about precipitation? Did you have any observations? Or
precipitation wasn't really helpful for predicting the temperature. Most of the features that were related to precipitation, we had to remove them from the feature. So I'm curious to know what features would be predicting that as well.
Yeah, I mean, this is a subset of, like I said, a bigger data set, and that had a lot of other weather variables, that there was precipitation, there's also wind and snow, and that's part of precipitation. And I mean, this was just a sample for people to get used to weather modeling. I mean, in reality, weather modeling is very, very complex. And the idea behind these models is to sort of pick up both the cross-section and the time series. And, there's a lot of physics-based models that are built into, these models to pick up the dynamics of weather prediction. And that was the idea of, giving this kind of model development to the competition, to the competitor, just to kind of have this experience of weather modeling. It's not the most, it was just to give a taste of what it's like. Once you really get into this field, it can be very complicated. And, that's why I asked the question, did you feel like, you really got interested in this field, because it's a very interesting field. There's a lot of mathematics and physics involved in weather modeling, and it's something that you can open this competition, kind of open doors to a big field of research, which is very pertinent right now with all the climate disruptions that are happening. So that was kind of our thinking and our rationale when we chose this data set and when we researched this data set and prepared it for the competition. So that's just coming from our side, and hopefully, you all enjoyed the challenge, and learned something from it, and learned something that you'll take with you, after this competition.
I'm curious at a high level from each of you, what was your biggest takeaway and your biggest learning, whether it be a skill or whether it be within the domain of this challenge? What was your biggest takeaway from your participation?
For me, probably that it's important to start with simple models that you could run very fast, so that you could iterate quickly on your research. Because if you start with models that take an hour or two to run, at least I would get very demotivated with just waiting for the results each time.
Yeah, so for me, it was a great opportunity for me to practice data science skills and courses that I only had at theoretical level. I had to apply them here in a real competition, and seeing our rank in the Kaggle was motivating us to work on the problem more and more. And there was a lot of skills that I learned. It was ensembling different models, and the fact that you can use different features for one model and another set of features for another model and just combine them together was one of them. Yeah.
Where do you think you'll go with this now, with all these things that you've learned? Is there a thing that you can go forward, or a path that you might not have had ordinarily, but now you have discovered a new path that you'll go with what you've learned from this competition?
So I applied data science at work extensively, so I guess I'll try these methods at work also.
Yeah, I would like to participate in more of these competition, and also if there was any opportunity at work for any data from the client that we have, I can use the insights from this competition, and would like to compete in more and just use the experience that I had from this one to apply in other data sets. But I think at the same time, we have to be creative. You cannot use exactly the same method, obviously, but it's a good starting point. Yep.
Do you have any advice for our competitors? Many of them are beginners, some of them are intermediate, and some of them are advanced. Do you have any advice for our competitors all over the world who are going to be looking at you, your recording? Anything you can tell people based on your experience?
Probably a very simple thing. Maybe it was said a lot of times, but EDA is very important. So just exploring the data and trying to understand the nuances of the data. That should, for us, I think it took maybe half of the time.
I'd say teamwork is a great in this kind of competition. You can motivate each other and give each other great ideas. Sometimes if you are doing the competition solo, there are many times that you can give up easily. But if you have someone that you are motivating each other, that would be a good thing for making you go forward. I remember in this competition, it was Friday night. I was really tired and I was exhausted, but I received a message from Evgeny saying that I've tried this method and our rank is higher. I got really motivated and I jumped to my laptop and worked on his notebook, and I could improve the score even better. I wouldn't work that Friday night, even I hadn't get a message from Evgeny. So I think teamwork is really great at these kind of competitions or work, data science work in general. Yeah.
That's fantastic. We're really happy to hear that. I mean, at WiDS, we try to provide resources. We have many, many forums, and we interact with people, and finding a good teammate is sort of one of the big messages that we send. Interact, network with people, find people that you can work well with and learn well with. So this is just wonderful for us to hear. Another question I had is, are there particular resources that were useful to you, as you're building your model? I know Kaggle, our partners here, have tremendous resources. There are lots of books on the internet. Were there any particular resource that you found useful?
So for me, looking through the white papers of different approaches to solving this problem. So usually predicting the weather problem is stated differently. So I guess we're at time t and we know nothing about the future 2 months of data. So we actually had predictions from the physical models, which we wouldn't have in real life, and we had data about the precipitation, which we wouldn't have in real life. But nevertheless, when you read ideas, even if you can't apply them directly, you sometimes come up with new ideas. So I think just this process of reading through the articles helped me a lot.
Yeah. Were there sort of technical articles, or there general articles, or there sort of mathematical articles, or is there all over the place?
Technical weather prediction articles.
Oh, that's very good.
For me, tutorials that were published by WiDS on the Kaggle was great. Some of them, I mean, at least to get you started, they were great. I really like them. Yeah, I recommend attending the workshops and also following the tutorials, especially at the beginning, to have a good understanding of the problem, and then try to improve that afterwards.
So one more great resource are the Kaggle notebooks that were shared by other participants. They were extremely helpful. And I think someone found that the latitudes and the longitudes in the train and the test set, they do not correspond exactly to each other. That would probably take us hours to figure out, but we had access to this information right away because someone published it.
Yeah, it's a very active forum. A lot of people work together. A lot of people share their findings, and that's the beauty of Kaggle, is that it's a highly interactive forum. And if you take advantage of it, you learn things. Things move at a much faster pace, for sure. Yeah. I'm also I think I mean, another question I had is, I mean, we were as a forum with is really looking forward to, encouraging younger, sort of competitors that are earlier in their stage, and we're hoping that you will come back to WiDS and participate in our forums and participate in various events that we have. So how have you sort of gotten resources from WiDS and some of our forums, and do you have plans to come back to WiDS? We definitely hope that you will.
So we took part in last year's competition. It was also Team Zephyr, and I think we placed 4th last year. I think WiDS competitions are really fun because the problems are not too difficult, and data scientists that are just starting out could easily try something out here. So yeah, I think these competitions are very fun, and we'll try next year.
That's fantastic. That's what we want to hear. We really want to hear great engagement. We want to hear that you're coming back, and we'd be really excited to have you guys come back and participate in our forums and work with people who are fresh in our forums, and who are looking to kind of break down barriers and make things more accessible. I mean, I hope you can appreciate a few years ago, these resources were not available. I mean, at least a decade ago, or when women were starting to do very difficult technical things, they didn't have these resources available, and so they were pretty much on their own, and they had to find out, do your research, break down all the things, and figure things out for themselves. So that's why WiDS was started as a resource for women and men, for them to gain difficult technical skills and find partners along the way. And it's wonderful for us to hear that you're using them, and that it was useful to you in your own journey. And there's a lot of effort that goes on behind the scenes to bring these resources to you, to bring these tutorials to you, to design all this competition. So it's really wonderful for us to hear that it was useful to you, and that you benefited from it, and you're at a different point in your journey than you were before. So that's really wonderful for us to hear. And I think that competitors around the world, will be really inspired by your journey. And hopefully, there's somebody out there who's daunted, who finds data science daunting, and they hear your journey, and they decide to, take a step forward and try something new and gain some skills. And that's what we're really hoping for. I mean, so far we've reached thousands of people, 25,000 people all over the world. And that's really the purpose of WiDS. And we're really, super, super happy, super thrilled that you made such a great effort, and that you got so much. And again, congratulations on a fantastic performance.
Thank you.
Yeah.
Thanks so much.
Yeah, congratulations.
Thank you.
Do you have any final comments or anything else you'd like to share?
I can't think of anything else. But I really appreciate it. It was a great opportunity for us to practice our skill, learn new things, network with each other. After this competition, I got a lot of friends in LinkedIn, and I think I have access to a broader community, which is great. Thanks so much for that.
Yep. Thank you for organizing the competition. I imagine it was a lot of effort and a lot of work. Thank you very much.
Yeah. Well, we're welcome, and we are super thrilled that you got a lot from it, and that's all we were hoping for. And thank you for participating, and thank you for a lot of hard work on your side, and we appreciate that.
Great. Congratulations from Kaggle as well. And yeah, okay, we'll stop recording now.
Thank you.